about today how to solve systems by elimination. And guys, it is really best, you can use it for other things, but it's best to use when both of your equations are in standard form. Alright guys, so it's really nice to use when both of your equations are in standard form. And guys, linear standard form is that ax plus by equals c. Alright guys, now remember, to solve by graphing, it makes the most sense if both of your equations are in y equals. Alright, to solve by substitution, which is what we did last time, it really makes the most sense if if one of your equations is solved for something. So y'all, for example, I'm going to show you guys this lovely equation. You guys don't have to actually solve this real quick, but guys, if you were given two equations that looked like this, I would graph them. They're both set up in y equals. Does that make sense? Okay? If you were given two equations that looked like this, we did a couple word problems like this, guys. You had one value here. L was equal to something, so you could substitute it in. I would do substitution for an equation like this, okay? And then, y'all, if you were given an equation like this is about dimes and quarters, so that's why there's 0.10 and 0.25. If you were given an equation like this, we are set up in two standard form equations. This would really be the best for elimination, all right, guys? So today, when it's best to use when both of your equations are in standard form. And guys, our goal, the main goal of elimination is to have the coefficient be the same number but opposite sign. So we want to get our coefficient to be the same number but the opposite sign. That's our main goal with elimination. Alright, y'all? So, and what that does is that sets it up for our variables to eliminate. Alright, guys? So, I'm going to give y'all a lovely equation over here. We have x minus 2y is equal to negative 19. And then we also have 5x plus 2y is equal to 1. Alright? So the first step is you get one variable to have the same number but opposite sign. You might need to do that. You might need to multiply. You might need to do some things to make that work, and we'll go over that. But guys, that's the very first step. You need one variable has the same coefficient, or one coefficient, I guess one variable coefficient, has the same number but opposite sign. So if you're taking a look at this guy right here, it's actually already kind of set up for us, isn't it? So when you look at your x's, are those the same number? Your coefficients? No. Oh, what about your y's? Same number, opposite sign. Do y'all feel good about that? And so what you guys will do, the second step, step 2, is you add your equations together. And guys, what happens when you add the equation is one of your variables eliminates, hence the name elimination. Alright guys, so then we add our equations together, and what happens right here? Boom. Those guys go bye-bye. Do y'all feel good about that? So what are we left with over here? X plus 5x is 6x. Negative 19 and 1 is negative 18. Do y'all feel good about that? My y is eliminated, so nothing's there. So now, guys, step 3, you solve for the remaining variable. Okay? So hopefully this is not a super difficult solving. What is my x going to be equal to, y'all? X is equal to -3, because we divide both sides by 6, and we get x is equal to -3. All right? Do y'all feel pretty good about that so far? Okay. Once you have this new value, what do you think we need to do to find our y value? Yeah, you plug in the value to one of the original equations. All right, guys? And I would pick one of your original equations. And, guys, then you solve for the other variable. All right, guys? So, does it matter do you think it's going to matter which equation we pick? It will not matter. All right, guys? And so, in my first class, I picked the bottom equation. So in this class, I'm going to pick the top equation. So I'm going to say instead of x, I'm going to say -3 minus 2y is equal to -19. Do y'all feel good about that? Then we are going to add 3 to both sides. So -2y equals -16. So y'all, what is my y equal to? -16 divided by -2 gives me 8. Okay? And last but certainly not least, our step is to write the solution as an ordered pair. So that would be -3, 8. Do y'all feel good about that? So this right here would be our solution. So guys, elimination is not too bad, but it is following that set of steps. You solve for one variable, then you have to plug it in and solve for the other variable. Do y'all feel good about that? All right. So, and guys, like I said, I did it the other way. I did it with the other equation in my first class. So check this out. I did 5 times -3 plus 2y. So then I had -15 plus 2y equals 1. Added 15 to both sides. 2y equals 16. Look at that. My y was still equal to 8. So it really doesn't matter which equation you pick as long as you pick one of the original ones. Cool? All right. So this one, I plugged it into the top equation. This one, I plugged my -3 into the bottom equation. But both ways, we got y is equal to 8. Because, y'all, if I was going to, what's another way I could have solved this equation up top without elimination? Is there any other method that we could have done? They're both in standard form. But guys, what if I transformed it into y equals? Yeah, we could have substituted. If we'd done this way, we could have added the 2x. Guys, if we had transformed this into y equals and this into y equals, could I have graphed them? So if I put them both into y equals, we could graph it. Guess where they would intersect? -3, 8. All right? So now we're going to do a couple little examples where we actually have to manipulate some stuff. All right? So example number 1 here. I'm going to have -2x plus 2y is equal to 10. And then my second equation is x minus 5y is equal to -9. So y'all, for this particular equation, are any of my coefficients lined up so that they're the same number but opposite sign? No. My x's aren't and my y's aren't. Is there anything I could multiply one of my equations by to make that happen? Is there any way I could manipulate this equation in order to make that happen? Miss Maria, can you help me out? Is there any way I could get these two guys to line up with each other so that they could eliminate? Okay, I can multiply it by what? Ooh, okay. Well, if I multiply by negative 2, then they would both be negative 2. So if I just multiply by positive 2, then it's the same number but opposite sign, right? Because we want that opposite sign. So if we multiply this entire equation by 2, that makes my bottom equation now be 2x minus 10y equals negative 18. Do you guys feel good about that? And guys, I will tell you right now, the most common mistake I see with elimination is you will multiply 2 times x and 2 times negative 5, and you'll forget about that negative 9. So do not forget to multiply by everything. Do I need to change my top equation at all? Nope. So I'm going to just rewrite it over here. 2x plus negative 2x plus 2y equals 10. Now, do I have it set up so that they will eliminate nicely? I sure do. So guys, what's going to happen to those x's right there? Bye-bye. Now what happens to my y's? 2y minus 10y is negative 8y. 10 minus 18 is also negative 8. So guys, how do I solve for y? Yeah, we just divide. So you divide by negative 8, so my y is equal to a positive 1. Do y'all feel good about that? So that is my y value. Now that we know my y value, we want to plug it into one of our original equations. Now, y'all, it is important to always go back to those original equations because you could have accidentally messed up when you multiplied here. You don't want to mess up twice. If you're going to mess up, only do it once, right? So plug it back into your original equations. So does it matter which equation we plug it into? Which one do y'all want to do? Weston, which equation do you want to pick? Perfect. Let's do it in the top one. So we have negative 2x plus 2 times y, which is 1, equals 10. So that's negative 2x plus 2 is equal to 10. So then I subtract my 2. So I have negative 2x is equal to 8. I want to divide by negative 2. So my x is equal to negative 4. Do y'all feel good about that? So my solution to this problem is negative 4, positive 1. That is the ordered pair where these two lines would intersect. Does that make sense, y'all? So if I actually graphed these lines, if I transformed them into y equals, we would have added 2x divided by 2, so that would have been y is equal to, x plus 5, okay? And then if I subtracted my x divided by negative 5, so that's going to be 1/5 x plus 9/5. Yeah, because I would divide everything we have. So if I had actually put these in y equals and graphed them, well, y'all, look where they intersect with one another. Negative 4, positive 1. Second trace, intersect, enter, 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 negative 4, positive 1. So, y'all, if you really don't like elimination, you could literally put every equation into y equals and just graph it. All right? That is one easy way to do it as well. But sometimes the numbers are just too big, or sometimes they won't fit on your little graph screen. So that's why it is nice to be able to know how to do it algebraically, but graphing is definitely an option. All right, so next we are going to take a look at, I'm going to do a couple more problems here. All right, so for number 2, what I want us to do is we are going to look at this equation. 2x plus 3y equals 6, and 6x plus 9y is equal to 18. Do y'all feel good about that? So what could I multiply by in order to get these two equations, either the x's or the y's, to line up? What could I multiply by? Negative 3. Let's multiply this top guy by negative 3. If we just multiply by 3, it wouldn't be enough. So that negative 3 would turn this into negative 6x minus 9y equals negative 18. So then I'm going to rewrite my bottom equation, and as you're writing it, you might notice something. What is going to happen to every single variable here? Oh, my 6x cancels, and my 9y's cancel to leave us with 0. But look, negative 18 plus 18, that also leaves us with a 0. So y'all, if all your variables cancel, that's a special case. So if all your variables cancel and you have a true statement, because guys, is this true or false? Does 0 equal 0? It is true. Then how many solutions do I have? Infinitely many solutions. All right? Or another way that you guys like to write that is with that all real numbers, right? So you could say, or we could also say the lovely little all real numbers. So you have infinitely many solutions. All right, guys? Now, question for you guys. This is what, or I guess statement. This is what an infinitely many solutions problem looks like if you solve it algebraically. You end up with a true statement. What does infinitely many solutions look like when you graph it? So if I graphed both of these lines, what would they look like? Yes, they would be the exact same line. So guys, they would be up on top of each other, right? They would be touching each other all over the place, right? Because they are infinitely many solutions. So guys, if these were graphed, they would be the exact same line. Y'all feel good about that? Excellent. All right. So if you're graphing it when it's the exact same line, that's what infinitely many solutions. If you're solving algebraically, this is what infinitely many solutions look like when all your variables cancel. All right. So let's look at another example here. All right. So I'm going to say 3x plus 6y is equal to 15, and 2x plus 5y is equal to 12. So y'all, is there anything we can multiply just one equation by to get these to cancel? So when you have a problem like this, you are going to have to multiply both of your equations. Does that make sense, y'all? So if we were going to multiply both of these, what could I multiply them? We're going to multiply different numbers. So what could I multiply the top equation by? Okay, if I multiply this guy by negative 2, I heard that, then we would have negative 6x minus 12y equals negative 30. Are we comfortable with that? Now, what would I have to multiply my bottom equation by? 3. Because then that would give me a positive 6x plus 15y is equal to 36. Are you guys comfortable with that? So now that we've multiplied both equations, one of my variables will eliminate. Before we move on, guys, is there anything else we could have multiplied these by to eliminate our y's? What could have I multiplied it by if I wanted to eliminate the y's? Positive 5 and negative 6. Does that make sense, guys? So it just kind of depends on which one you want to eliminate. There's not really a right answer. Usually, I try to eliminate the x's because they're the ones in the front, but you can pick either one. Does that make sense, guys? So as we eliminate these, we see that our x's are gone. So now what are my y's equal to? We got 3y is equal to 6. If we divide both sides by 3, my y is equal to 2. Do y'all feel good? Does that make sense? Are we tracking? All right, guys? So my y is equal to 2. Spoiler, if you guys are doing this on multiple choice problems and you find one of your values, well, guys, that means you can immediately go to all your answers, and anything that doesn't have y, have a 2 in the y, it's not the correct answer. So you could eliminate some of your answer choices right away by just knowing at least one of your values. Does that make sense, guys? Okay, now that we know this value, what we gonna do? Plug it in. All right, so Eric, can you tell me which equation would you rather plug it into? The first one or the second one? First one. Sounds great. There's really not, I mean, both of these have positives, whole numbers. Like, there's honestly not a better equation on this one, okay? So we would say 3 times x, or 3x, plus 6 times y, which is 2, is equal to 15. So that's 3x plus 12 is equal to 15. So now I subtract my 12 from both sides, and I have 3x is equal to 3. Divide both sides by 3, and my x is equal to 1. So if I wanted to write this out in my ordered pair format, I would write it out as 1, 2. Does that make sense, y'all? Are you guys tracking? And if we had solved these both for y and graphed them, they would have intersected at 1, 2. Cool? All right. We're going to do one more quick little example, and then I'm going to do a word problem with you guys, okay, so that we can feel really good about these word problems. So we have to create, and then we got to write it. All right, so let's take a look at this here. So we are going to do negative 4x plus 4y is equal to 6. X minus y is equal to negative 6. All right, so we are going to have to manipulate this a little bit. I don't know why I did my y's differently. That's going to bug me. I'm going to rewrite it. Okay. All right, so what can we multiply something by to cancel? We can multiply the second one by what? 4. Could I also have multiplied the top one by 1/4? Sure, but then you would be dealing with a fraction. Do you really want to deal with a fraction or a decimal? No. So keep it with whole numbers if you can. But there's really not just one right way to do this. You could do this a few different ways. So this becomes 4x minus 4y equals negative 24. Don't forget to multiply that last one. Okay? And then up here up top, we have negative 4x plus 4y equals 6. Not negative 6, just 6. So now, can we add our lovely equations together? Yes, we can. What happens, though? Both our variables cancel again. We're left with 0. Ooh, do my constants cancel? No, we're left with negative 18. What kind of statement is this? True or false? So how many solutions do I have? I have no solutions. So y'all, if your variables cancel and you're left with a false statement, so if your variables cancel and you have a false statement, then you have no solutions. All right, guys? So this is what it looks like algebraically. This is what no solutions look like algebraically. What do no solutions look like graphically? They are. They would be parallel lines. So if we graphed these, they would be parallel lines because they would never intersect. Y'all feel good about that? Okay. Now, our last little thing that we are going to do here is we are going to now create a problem, and then we are going to find the solution. All right? So let's take a look at this guy right here. A hotel offers 2 activity packages. One costs $192 and includes 3 hours of horseback riding and 2 hours of parasailing. Gosh, so that's one package. The second package costs $213 and includes 2 hours of horseback riding and 3 hours of parasailing. Have any of y'all ever gone parasailing before? Okay, so I got to go way back a long time ago, and it's crazy. You think it's going to be this like thrilling thing, but like it's pretty exciting once they when they put you up, because they like harness you up and do all this stuff. But once you get up there, you're just gliding, and it's like super calm and quiet and peaceful. It's like you're riding like a Ferris wheel, but there's no bottom, so you just get to like look at the ocean, and you're just gliding in the air, really calm and quiet. And you're like, you think it's going to be this like really like hang gliding experience. Nope, it's just you're just hanging out, watching the beautiful ocean. It's really cool. So it's really relaxing. But then when they reel you back in, it gets a little bit like, because we were like on like a winch, so they unwound us and then they wound us back in. It was kind of cool.
I'm just gonna go this summer, but that sounds boring.
It's really cool, but it's not thrilling.
I like thrilling.
Yeah, it's not a thrilling experience. Does that make sense?
Yeah.
But it's a very neat experience. All right, so guys, how are we going to write this? Okay, so we have some horseback riding and we have some parasailing. Are we cool if we use the letters H and P? All right, so what are we looking for? What is the information we don't know? What's the information we don't know, y'all? We don't know the cost of each. So guys, we don't know what the cost of horseback riding is. All right. And we don't know what the cost of parasailing is. So guys, we might know the emotional cost, but we don't know the actual physical cost, okay? So we don't know what the cost of horseback riding is and the cost of parasailing is. So we are going to have to write some equations to figure this out. So y'all, my first equation in my first trip or my first activity package, we have 3 hours of horseback riding and 2 hours of parasailing. Do y'all feel good about that? And how much did that cost me? $192. So this would be a great first equation. What would be a good second equation? Will, can you help me out? So our first one was 3 hours of horseback riding and 2 hours of parasailing for $192. So what would we do for our second equation for the second package here? Yeah. 2H plus 3P is equal to 213. All right, guys? So now that we have our 2 equations, why does it make the most sense to do this one with elimination, y'all? They're both in standard form. Now, they're not super beautiful. We're going to have to get them. We're going to have to manipulate them to get them to line up, but it's not going to be that hard. Okay? So, Miss Rika, what would you multiply your top equation by?
-2.
Awesome. Let's multiply that guy by -2. So that would give me -6H minus 4P equals, what is that? -384? Because -2 times 192, yep. Okay. 384. Then what are we going to multiply our bottom equation by to make sure they line up? +3. So that would have been 6H plus 9p is equal to 3 times 2, 13. That's 600. 13 times 3, 39. So 639. Cool? So now, what would we do? So now we can find the cost of we can eliminate our h, right? So if we eliminate our h's, what do we have left over? 5p equals, can someone do that for me? 384, 255. Excellent. So we divide both sides by 5. So how much does each hour of parasailing cost? 51 bucks. 255 divided by 5 gives us that 51. Not exactly sure why they charge 51. Don't know what that extra dollar is for, but cool. All right, yeah, it's the emotional cost there. 50 plus $1. All right. So now that we know our cost of parasailing, what are we going to do to find the cost of horseback riding? Plug it in. So we'll go here. Does it matter which equation we pick? No. I'm going to pick the top one because my numbers are a little smaller. Y'all cool with that? So I'm going to say 3h plus 2 times p, which is 2 times 51, equals 192. So that's going to be 3h plus 102 equals 192. There we go. Subtract 102 from both sides. So my 3h is equal to 90. So how much does each hour of horseback riding cost? 30 bucks. So guys, is there a way we can check ourselves on here? Is there a way we can check ourselves? Guys, this is when I recommend plugging it in. So I would go here, kind of trying to find this here. I would go here and I would say not in y equals. I would say 3 hours of horseback riding, so 3 times 30, plus 2 hours of parasailing should cost me 192. Yay. And 2 hours of horseback riding and 3 hours of parasailing should cost me 213. Yay. All right, guys, so that is a great way for us to be able to check ourselves. All right, do y'all feel pretty good about this? For these guys right here?
I can see the board perfectly fine. Leave me alone.
All right, guys. So up next, guys, what I'm going to do is I'm going to give you a lovely little piece of paper, hold on, that has all these word problems on them. But they're multiple choice. You guys are going to have to select the correct word problem. Does that make sense, guys? And then on the back, you guys are going to set up your word problems. There's a little flash of all the right answers. But you guys are going to have to set up your word problems. And then you guys will have to decide the best method for how to solve those. All right?